Hello and welcome to Sonic State. Today we're going to be taking a look at the Coma Electronic FT201. This is an analog filter with a built-in 10-step sequencer. So what does that mean? Well, basically this sequencer is used to sequence the cutoff frequency of the filter. This is a voltage controlled analog filter with variable outputs. So we have bandpass, low pass and high pass. We also have an infrared sensor for patching either back into the pedal or to external voltage controlled gear. So let's have a look at it and see what it sounds like. So let's have a look around the back. What we have here is 9-volt DC input, and then we have these 4 trimmer pots. That's 3 for the CV inputs, so sequencer, cutoff and resonance, and then we have this sensor output. So basically these are attenuators for attenuating either the incoming control voltages or the output of the sensor. So on the front panel we've got the audio output, so that's high pass, band pass and low pass. We then have the sequencer output, which is basically the control voltage created on each step of the sequence. So on each step of the sequence we get an added control voltage based on the position of the cutoff frequency. So if we higher or lower the cutoff, we will get a higher or lower control voltage output from the sequencer. So then we have the sensor output, and next to that is the sequence reset input. So we can use a control voltage to reset the sequence like so. So taking the sensor output, we can patch back into the sequence reset, and then as we hold something over the sensor, we can hold the sequence on the first step or reset it at any point during the sequence. So then we have the CV inputs for resonance, cutoff and the external clock speed. So basically we can clock the sequencer to external modular gear. And then underneath that we have the sequence speed knob. So basically this is just the speed of which the sequence plays back. So all the way to the left is as fast as we can go and all the way to the right is as slow as we can go. Then we have the sequence length knob, so this is a click wheel knob, feels quite nice, quite sturdy, and we can go from 2 steps all the way up to 10. So then we have the cutoff and resonance controls and input gain, so we can use this to either boost the incoming signal or we could use it to distort the incoming signal into the pedal. Then we have an on and off switch. Notice how the sequencer still runs even when the effect is off, which is quite a nice feature. And then we have the sensor underneath. So this is just an infrared sensor which is accessed via the sensor output on the patch bay. So let's hear what it sounds like. So first of all what I'm going to do is just give you a sawtooth wave, and I'm in the low pass output, so let's hear what it sounds like. And then add a bit of resonance. And then put the resonance all the way to the top, as this thing will actually self-resonate, so you can hear that nicely. So let's try it in the bandpass output. So no resonance. And then a bit more resonance. So let's try the high pass output, starting from the top this time. Adding a bit more resonance now. So let's hear what it sounds like once we start sequencing the cutoff frequency. So back in the low pass output, and on each step of the sequence we will get added control voltage to the position of the cutoff frequency. So if we move the cutoff up, we would get added voltage from this point onwards, etc, etc. just going to drop the pitch of the oscillator down. And then let's try it in the bandpass output. So still the same sequence. Really high resonance now. And then let's try the high pass output. So if you speed the sequence up, you can get some really nice kind of drippy, almost vocally sort of sounds. So let's stop that and then play around with the sensor. So I'm back in the low pass output, and I'm going to patch the output of the sensor into the CV input of the cutoff frequency. So as you move your hand over the sensor, you'll hear the cutoff frequency start to open like so. So let's try something else. Let's try patching the sensor into the sequence reset and hear what that sounds like. So obviously as I move my hand over the sensor, I'm resetting the sequence. So I think where this really starts to come into play is when you start patching it with other modular gear. So let's get something together and we'll see where it takes us.
So in this patch I'm using the sequencer to sequence my pitch, but it's also sequencing the filter of this patch. So what I've done is mult the output using a stack cable to these two oscillators. That's why it doesn't sound very musical, but still quite effective. And then the rate at which the sequence is playing through is controlled by this LFO here. So you can see as I turn the LFO up, it runs through the sequence much quicker. So the outputs of both the oscillators are mixed and then sent into the Coma Electronic Audio in, and then that output is then put into a VCA here, this exponential VCA, which is then controlled by this envelope here. So then what I've also got going on is I've put the sensor output into a VCA here, and that's been multed again, so it's also controlling the cutoff frequency of the Coma Electronic, so also controlling the pitch. So if I move over the sensor, you can hear the pitch go up. But there's also some other modulations going on controlled by the sensor. So if you put your hand over the sensor, you'll get some random voltage frequency modulating both the oscillators. So I've got random CV from my Doepfer there into my VCA here, and then that output is going into both the frequency modulation inputs of both my oscillators. So I've also got some resonance modulation as well, and that is controlled by the right hand side of my Vulcan here. If I turn this attenuator up, you'll start to hear that. So that's pretty much it from this patch, apart from a little bit of reverb from the Doepfer Spring Reverb. Yeah, I just wanted to show you a quick way of getting to grips with it and using it in a fun and creative way.
So overall, I'd have to say I really like this pedal. I think it sounds really great. It's got a very nice smooth character to it. So I think that's definitely because it's a Vactorel filter. So it's just generally got that really high quality and it doesn't distort very easily. Or when it does distort, it distorts in a really nice, smooth way. A couple of things that I don't like about it, however, are the slider pots for input gain and resonance have these crappy little plastic caps on them which tend to come off very easily, and they could be lost. And I think if you were transporting this around in a gig bag or something, then yeah, it would get lost or knocked off easily. Another thing that I don't like about it, and this is definitely just because I use Eurorack modular stuff, is that it's on 1/4 inch jacks. So I find myself having to search for adapters and cables that will work. So that's kind of just a Eurorack thing. In comparison to the two other filters that I've got a Borg 2, which is a state variable Vactorel filter as well. The Borg doesn't have as much voltage control over it, so the Koma wins in that respect. Although I found that the Borg, generally you don't have to work as hard with it to get it to sound really good, whereas I find with the Koma you have to work a little bit harder, but then it can sound just as good, if not better, in some situations. The other filter that I've got is a Tip Top Audio Z2040, so this is just a low pass filter, and in comparison they've got a similar sort of feature set in terms of voltage control, but I kind of prefer the Koma. It just sounds a little bit better, but then they're kind of two totally different filters, so you can't really compare them very well. So yeah, overall a really great product. It's 354 euros, so it's not cheap, but then I think for the feature set that you get with this, I think that's fair enough. I don't think the price is a problem. So yeah, that works out about £290. So overall, a really great product, big 2 thumbs up from me. And yeah, so thank you for watching and see you next time.